So we're going to look at solving equations with variables on both sides, which is section 1.3. So here we go. So core concept to solve an equation with variables on both sides, simplify on both sides of the equations if necessary, and then use inverse operations to collect the variable on one side and collect the constant on the other. So what we're going to be trying to be doing here is isolating that variable, getting that x in most cases by itself. You'll see it's going to be on both sides to start, and then we can solve from there. So it doesn't matter which way you go about doing this. So if we have 10 minus 4x equals negative 9x, you could add the 9x over, or we can add the 4x. Now, if we want to get this 10 by itself, our best bet, let's isolate this 10 and start by adding that 4x over to both sides. So we're using inverse operations here, okay? Because we want to get rid of that 4x. So the 4x is gone over here, and we're just left with the 10, which is what we want, our constant on one side, and then our variable on the other. And then negative 9 plus 4x is going to be a negative 5x. From this point, we could isolate that x, which is our goal. We want to solve for x, so we want to get this x by itself. Hopefully you're thinking to yourself, okay, I'm multiplying by negative 5 here, negative 5 times x. So in order to get rid of it, I have to divide by negative 5. Notice this is multiplication, it's not subtraction. Some people may think I have to add the 5, but we're multiplying there. 10 divided by negative 5 is negative 2. This will cancel out. And the reason it's canceling out, guys, is because negative 5 divided by negative 5 is just equal to a positive 1, which means that it can cancel out and you're just left with 1x or x. So x is equal to negative 2. If we wanted to check this, we could check our work by taking that negative 2 and plugging it back in for x in both sides. So now we're going to get 10 minus 4 times negative 2 equals negative 9 times negative 2. Negative 4 times negative 2 is a positive 8. So we have 10 plus 8, which is 18 here. And then negative 2 times negative 9 is positive 18. So we have positive 18 equals positive 18. So we know that we've got the correct answer. Just one more to try. Let's subtract the 3x from both sides. And we're going to be left with negative 5x is equal to positive 10. Divide by negative 5. And x is equal to negative 2. There's some more going on in this problem because now we've got some parentheses involved and we have to deal with those. So the first step we're going to do here is we're going to distribute. So when we distribute here, 3 times 3x, we're going to get 9x. And 3 times negative 4 is going to be negative 12. And that's going to be equal to 1/4 times 32 is 8x. And 1/4 times 56, if we multiply that out, is going to be 14. So now you have variables on both sides with our x's. And then you have constant terms on both sides with your negative 12 and your positive 14. So it really doesn't matter what you do. Okay, you can move the 8x, you can move the 9x, you can move the 12, you can move the 14. You've got options. Any of those things will work. I'm going to subtract the 8x because I always like to keep my variable on the left side. So I'm going to subtract my 8x, and now I'm going to be left with 9x minus 8x, which is just 1x, or x, minus 12 is equal to positive 14. If I add the 12 to isolate the x, I'm going to get 1x equals 36. And if I divide by 1, I don't even have to do that. Oh, 26, not 36. I'll get an x value equal to 26 as my solution. So a couple more steps on this one, but still not too bad. Here's some more with the work shown. Now, sometimes we have some special cases, okay? And some special cases of a linear equation occur when we have no solution or we have what's called an identity. And an identity means we have infinitely many solutions. That happens when your x's cancel on both sides. So we can see on the left example here, we've got 5x plus 6 equals 5x. You subtract the 5x from both sides and you get 6, which is not equal to 2. So this is a statement that's not true, so we end up with no solution. Here, when we subtract the 5x, it cancels on both sides, and we're left with 6 is equal to 6, which is a true statement. That makes it the identity, which means there's infinitely many solutions. Here's two examples that are showing this, okay? On the left-hand side, we're distributing that 3 first to get 15x plus 6 equals 15x. When we solve for x here, what happens is we end up canceling on both sides. We get 6, which is not equal to 0, so we have no solution. On the left-hand side, we end up getting, and you can tell it's the identity if you see that the left-hand side is exactly equal to the right-hand side. You don't even need to go to this next step here. If you wanted to, you can. You end up getting x is equal to x, which means that we have infinitely many solutions here, okay, which is the identity. And here are just some more examples of that. Okay, that's it for today's lesson. Good luck.